Welcome to The Explainer. We're going to talk about an API vulnerability today that's, well, a little different. It's not about stealing your data. Nope. This one can literally bankrupt your company in just a few hours. Let's dive into what's called the unchecked API.
Yeah, $18,000. That's not some abstract number I pulled out of thin air. That is a real price tag. It's the actual cost a company paid because one single misconfigured API was exploited for just 1 hour. Insane, right?
So what's the vulnerability that can cause that kind of damage? It's this one right here, OWASP API4 2023, better known as Unrestricted Resource Consumption. And you got to understand, this is a really critical flaw, not because someone's stealing your secrets, but because they are weaponizing your own stuff against you. We're talking massive financial hits and, yeah, complete service outages.
Okay, let me put it this way. Imagine you hand an attacker a corporate credit card, but this card has no spending limit, and it's directly tied to your servers, your cloud infrastructure, your third-party services. They can just swipe and swipe, spending your money, burning through your resources until there is absolutely nothing left. That's what this is. Now, this is the part that kind of blows my mind. Look at this chart. Detectability? Easy. It's easy to find this vulnerability. But its prevalence? Widespread. It's everywhere. So we know how to find it, but we're just not fixing it? And the consequence of that, well, it's severe technical impact. We're talking total denial of service.
Okay, so how does an attacker actually pull this off? How do they weaponize your resources? Let's break it down and look at 3 really distinct ways they can turn your own cool features against you.
First up, the SMS pumping attack. This is a perfect example of a direct financial hit. There was this real case where an attacker found an API endpoint for sending SMS one-time passwords, the login codes. Well, it was completely unprotected, so they just automated it, hammering it with thousands of requests. The result? 10,000 text messages sent. That cost the company $500 in 30 seconds. And since no one stopped it, they just let it run. An hour later, the bill hit that $18,000 mark we talked about.
All right, next up, let's look at how this can be used for data exfiltration. Take a look at this request. Just a simple GET call to API transactions. Seems totally harmless, right? I mean, it's a standard feature. But what do you think happens if there are no limits on how many transactions that one call can return?
Well, this is what happens. A single, simple-looking request can return a massive 500 megabyte payload. If you don't have proper pagination, breaking results into pages, or hard caps on how big a result set can be, you're in trouble. This doesn't just crush your network bandwidth, it basically hands an attacker a tool to scrape your entire database, one huge chunk at a time.
And for our final example, let's talk about a pure computational attack. Now, I love GraphQL. It's super powerful and flexible, but that flexibility, it's a real double-edged sword. An attacker can write a ridiculously complex and deeply nested query, like this beast on the right, and your backend will just try to fulfill it. That one request could trigger tens of thousands of database operations, just completely overwhelming your servers until they just fall over, crash.
Okay, so that's all pretty scary, right? With all these different ways to attack, financial, data, computational, how in the world do you defend against it? Well, the most important thing to get is that there's no single magic fix. There's no silver bullet here. You absolutely need a multi-layered defense-in-depth strategy.
Think of it like building a fortress. Your defense starts at the very edge of your network with your CDN. Then it moves inward through your web application firewall, your API gateway, and all the way down into your actual application code. The whole point of layering is that if an attacker is clever enough to sneak past one layer, say they get around your WAF, they're going to get caught by the next one. Maybe an application timeout catches them or an infrastructure spending alert goes off. One layer backs up the other. Okay, so let's get practical. Let's dive into some of the most critical, actionable things you can actually do to build out those defensive layers.
First things first, rate limiting. This is the heart of a good defense. And the gold standard, the algorithm everyone uses, is called the token bucket. There's a reason giants like AWS and Cloudflare use it. It's really flexible. It basically allows for normal, bursty traffic from real users, but it shuts down the kind of sustained abusive traffic that attackers use.
But here's the catch. You can't just set one rate limit for your whole API and call it a day. That's not going to work. You have to think in terms of context. You'll probably have a general, broad limit for each IP address, just to stop basic floods. But for your really expensive operations, like generating a big PDF report or, sending that SMS message, you need much, much stricter rules for those specific endpoints.
Remember that crazy GraphQL attack we talked about? Well, for that, you need special defenses. A simple rate limit of 1 request per second is useless if that one request can crash your server. Instead, you have to implement specific GraphQL guardrails. Things like limiting how deep a query can go, calculating a complexity score to reject queries that are just too demanding, and limiting how many things a user can ask for in a single batch request.
And what about protecting your wallet from those financial attacks? This is your last line of defense, your ultimate safety net. You have to go to your third-party providers, your Twilio, your OpenAI, whoever, and set hard spending limits and real-time alerts directly on their platform. Because look, if an attacker somehow bypasses all your other controls, that hard spending cap is what's going to stop the bleeding and save you from an $18,000 bill.
All right, so we've looked at the problem, we've seen the scary ways attackers can exploit it, and we've walked through how to build a layered defense. So, what's the one core idea that ties all of this together?
Really, if you only remember one thing from everything we've talked about today, what should it be?
It's this phrase, think in limits. That's it. Every single call to your API consumes something. It consumes CPU cycles, it consumes memory, it consumes bandwidth, and a lot of the time it consumes actual real money. Your job as the person building or defending this system is to define what those limits are. Because if you don't, I promise you, an attacker will be more than happy to define them for you.